I am going to have my presenters come up and present. Originally, I would have you come back to your seat so that everyone's attention is up to the front. But as long as I have everyone facing forward, no one writing on their whiteboard while people are presenting, I will allow you to sit within your groups. Deal? Deal. Okay. Let's start with question number 1. Can I have group 1 come up here and present on what they think the slope represents? Shh. You want to pull out your red pen. You are making corrections if you need to on your lab sheet. You're the one who wrote it. This is important. All right. Let's get everyone's attention to the front. Okay, go ahead and start.
The average speed of the car. You have y2 minus y1 over x2 minus x1. Basically distance over time.
Distance over time. So you found the slope. That gives you distance over time, but how did you know? What gave you a hint? Your physics helper? Oh, that's cheating. Can anyone help them out? Did you guys get distance over time? Did you guys get the average speed for your answer? I hope so, because that is correct. But for those of you who did not use the physics helper, what was the clue that let you know that that value represents speed? The textbook. Besides distance over time. What was the unit of your slope?
Distance over time.
Distance for time, but it was a specific unit of centimeters per second, right? The reason why we did the warm-up was to look over all the different units that could potentially be a unit for speed. And I don't know, was centimeters per second one of those? Anyone remember? What? Centimeters per second is a speed unit. So, first question, your answer is speed. The unit of your slope was what gave it away. For those of you who didn't look at the textbook or look at the physics helper. All right, let's give group 1 2 claps. Group 2, what does the sign represent?
Get it. Oh, you know. Good job.
always ready to represent. I like it. I had multiple whiteboards right here. Oh my goodness. Okay, focus.
All right. Our question was, what did the sign of the slope represent? And our answer was,
The sign of the slope is the direction. Positive slope means forward, negative slope means backward. Remember how when we did forces, I said right means positive, left means negative, up means positive, down means negative? It's the same for kinematics. In this unit, you guys put down your ruler sticks however you wanted to put it down, but it is always going to be that same type of orientation that you use for your coordinate system. So direction. Any questions on number 2? Let's give group 2 2 claps. Question number 3. This one is related to the y-intercept. Notice how I split the different parts up one by one. All right, question number 3.
It just says the y-intercept represents the position of where the truck starts.
Starting position, you guys agree?
Yes.
Very good. 2 claps for group 3. And notice how in the forward motion, you were able to drop the y-intercept, but in the backward motion, what happened? What did you have to do? Please give me words, Karsten. You had to make it go up. It was the first time I think in this class where your y-intercept and your y-max value were exactly the same, at least for most groups. So, yes, that does happen. You can have 100% as your 5% rule, and you would definitely keep the y-intercept. Any questions for group number 3? Let's move on to the general model. We did 1, 2, and 3 simply because I wanted you to get set up for the general model. So let's have group number 4 come up here.
The general model is y equals mx plus b.
The general model for a linear graph is y equals mx plus b. How can we make this the general model for our graph that we created in this particular lab? All right, so what I see that this group has is they have some values. One thing is they added some units instead of variables. So we want to make sure for y, instead of centimeters, we want position. But I usually said it right. We want starting position. So Kiana, can you add this to, instead of centimeters, put starting position, or sorry, no, final position. Yes, then we're going to go over notation, yeah. Final position equals, they put slope, but what is our slope? What do we establish our slope was?
Velocity.
The velocity, aka speed, we'll talk about the difference between those two next. So then, instead of slope, Kiana put speed or velocity. And then, next to that, we have our x variable. Instead of seconds, we want the actual variable for seconds, which is time. And then we're going to add our y-intercept. And we established, based on group 3, our y-intercept is what? The starting position. So Kiana, go ahead and write y instead of y, starting position. Okay, so in your physics helper, you have this equation. It's not written out in words the way Kiana wrote it out as, but we have some important variables that we use to represent the position. That's x final. The speed, which we use as v for velocity. And then we've got t for time, that's pretty easy. And then xi, which is position initial. So when you guys use your physics helpers, you need to know what x represents. It represents position. You need to know what xf and xi represent. They represent initial and final position. And then instead of speed, we use velocity. Can anyone tell me why we use velocity and not just speed? What is the difference? Velocity and speed are basically the same thing, but velocity includes direction. So the plus or minus sign in front of your slope means that it's going forward or backward. With speed, in your car, when you're driving, you have a speedometer, but it doesn't tell you what direction you're going in, it just tells you your speed. But in physics, we want to know direction. So let's give group 4 2 claps. And I'm going to write down this very important equation. Go ahead and grab your whiteboard. Because this is the equation you're going to be using to do a lot of calculations. It is x final, that's your final position, equals v for velocity times t for time plus x initial. This is your constant velocity equation. We just came up with it from this monster truck lab. Let's go to group number 6. We're going to start doing some calculations with this equation.
You didn't joke.
Someone's gotta help Joe out.
I got it.
There we go. There.
Good job.
Okay.
So we plugged the numbers into our mathematical model and we got 756 centimeters for the position.
You guys agree?
Yes.
Pretty easy peasy. There's no starting position because we start at 0. Let's give group 6 2 claps. Problem number 7.
W.
Oh wait, I thought you guys got number 8. Wait, did we skip a problem? Problem number 6. Sorry, problem number 6. Group number 7. Problem number 6.
So we're trying to find how many seconds the truck traveled with a 10 centimeter head start and ending 75 centimeters. And this is our work.
5.42 seconds, you guys agree? So this one you're actually solving backward, and it starts at 10 centimeters, so you want to subtract the 10 first, then divide the 12, and then you should get 5.42. Were there any questions on that math?
So do you round to 2 decimals?
I'm not going to be strict about it. If you put 5.4, that's fine. If you put 5.42, usually I want 1 or 2. But yeah, 1 or 2 decimals. Any other questions? Let's give this group 2 claps. Come on, 10 claps. And then group 8, problem number 7. Hold on, why does group 8 only have? Oh, Roberto's going to be assessed. Sorry, guys.
Good question.
Amrua. Amrua. All right, go ahead and start.
Okay, so for the problem, we used the slope thingy, and then we plugged in the centimeters, and then the time, and we were solving for velocity, so just cut that.
15.7, you guys agree? Okay, which one's faster?
Truck 2.
Truck 2. Question number 8 is which one's faster? The first one was 12, this one's 15.7, so truck 2's got the higher velocity. Very good. Let's give group 8 2 claps. All right, y'all. Any questions on our constant velocity equation? Final position equals velocity times time plus initial position. What I want to do next, just because we had, did I have my groups? Did you guys already collect your candy for getting 0 position for group 1 and group 8?
No,
Are you lying?
I didn't.
All right, let me have you guys come up, but what I want you to do is explain to us what method did you guys use to collect your data to get such accurate information that your measurement was basically 0. What they calculated in terms of where they would land was the exact position in which they did land. So let's start with group number 1. We're all scientists here, y'all, so we want to learn from each other. What method did you guys use to collect your data?
We used the timer on the iPad, and so we turned on the truck and then we held it at 0, and then we released the truck and the iPad at the same time. And then the timer ran out, you got the truck and how far.
Okay, so
We did 2 seconds, 4 seconds, 6 seconds.
so your time interval was the interval that was independent instead of the distance. Okay, good. How many of you guys used distance as a set interval and then recorded the time? Everyone did the other? All of you picked a certain time? Really? Okay, so that was the same method my first period used. They chose time intervals also. You guys physically stopped it and then recorded the position. What about, did you have to do multiple runs then?
There were a couple of times that like the truck or something.
Okay.
Besides that,
pretty consistent. And then did you start it before the line, or did you start it on the line in terms of constant velocity?
We chose the bumper as a point, and then we put the bumper on 0, and then we put where the bumper was.
Okay, so you started it at 0 and then it accelerated into constant velocity. Okay. Group number 8, what method did you guys use?
Recorded the time after every centimeters.
So this group actually had set distances and you recorded the time. How did you record the time? Did you use
The time.
Did you use a slow motion camera?
Did once.
But it was just you just used it on regular recording. Okay. And did you do multiple trials or you just kept lapping it
We did, kind of like stopped it every single one.
and then started over?
Yeah.
Okay, so multiple trials. Yours was multiple trials also. I had a few groups that ran their truck all the way to 100 and recorded that time over and over and over again. Which groups did that method? I had a few in 6th period and I also had a few in this period. All right, I'm going to call you guys out. Group 4, you guys did that, right? You recorded every 100 centimeters. And that's fine. The data ends up looking like this. So we ended up with 0, 0. And then we had a kind of a cluster of data up here around 100 centimeters. So they actually got pretty close. 38 isn't terrible. I had a group that was like 100 off. But this is what we call modeling error. If all your data is clustered around the same place, it looks like a chocolate chip cookie, then you don't have enough information to get accurate data. And so I wanted some groups to actually do that. And I am glad that some groups did, because it highlights the fact that instead of having a nice linear path of points, we end up with a cluster of points. And I want to make sure that you guys realize that's not always the accurate way of collecting information. Any questions? Okay, what I'm going to have you do for the next several minutes is you're going to work on worksheet 1. We're going to only work on problems 1 through 3, which is based on analyzing position time graphs. When you get into page 3, it gets into drawing out velocity time graphs, which I haven't taught you yet, but I want you to try to do it on your own, and then we'll go over it together as a class. So keep your whiteboards for now. Work on worksheet 1. We're working on page 1 through 3, and then I'm going to have you do a little bit more whiteboarding before the end of the period.
Should we erase it?
You can erase it.